out if we're going to video. So it looks like we're going to have a quiz on, where are we? Over here. So tomorrow, no class. Monday, I guess Monday it is then.
What?
Quiz? No, that's just one section though, yeah?
That's so.
Yeah.
Yeah, let's do it Monday.
Is there gonna be a practice?
Of course there's going to be a practice quiz, but you got to actually do it.
Tuesday. I'm tired. We're bad on Monday.
Chewing gum. Get rid of the gum.
I'm sorry.
I told you guys. If you're going to chew gum, just make sure I don't see it. Okay, then you know what? We'll have the quiz next week, Friday. It's going to cover 11.2 and 11.3. Okay, we'll just do it. We'll do it. I think it's going to be a maxi quiz though. 30 points instead of 20. Why, you couldn't get a practice one? Okay, you know what? Why don't we do one? Let's try something. Let's have it without the practice quiz. No, wait. Let's do the 30-point with the practice quiz. Okay, questions on last night's homework. You guys said you guys had problems with 67? Okay, what else besides 67?
43.
43. It says, find all parts. We talked about this yesterday. Wait, what? Which section 27?
Yeah.
Well, I heard 43.
43 on the other.
Oh. That's okay, we should get this on video for the people who are not here. Okay, so first of all, it says find all the parts. Basically, that's what you gotta do. Okay, so does this parabola open up, down, left, or right? Well, since the x part is squared, it's either up or down. And since that's negative, it's gonna be down like this. Okay, so the vertex is at where? 3, -1. Okay? Now, this number in the front right there, that's 4p now. So 4p is -1. So Hoglin, this is what you're talking about, the fractions.
Yeah.
You don't like it when it comes out in fractions? Well, get used to it, sister. Okay, so p is -1/4. The negative just means it's opening down. So 1/4, that's what you need to know. The distance between the vertex and the focus is 1/4. So if I'm at 3, -1, and I go 1/4 down, I'm going to be at 3, -1/4. -5/4. Because that's 4/4, right? Yeah, 1 and 1/4. And then to get to the directrix, you have to go 1/4 up. Remember, the directrix is a line. So the equation of this line is y equals, if you're at -1 here and you go up 1/4, you're going to be -3/4. And then here's the axis of symmetry. And since it's a vertical line, it's going to be x equals 3. And then we have to find the endpoints of the Latus Rectum? No, but on my quiz you're going to have to. So let's practice that. Here is the Latus Rectum. Okay, let's get this out of the way. Focus, what was it? 3, -5/4, correct? So here's the Latus Rectum. You know what? I'm going to make it easy for you. You don't have to do the Latus Rectum then. But let's just do it for funsies. You know what? I think we need to do lattice rectum. The length of the lattice rectum is equal to 4p. So whatever number you have here, or if you take the absolute value of it, that's the length of the lattice rectum. So from here to here is 1. So that doesn't that mean 1/2 and 1/2? Okay, so if I'm at the focus, 3, -5/4. If I go 1/2 to the left, you're going to be at 2.5 -5/4, right? Because this is the focus. And then if I go 1/2 to the right, you're going to be at 3.5 -5/4. I just like to write 5/2 and 7/2 instead of 2. If you want to write 2.5 and 3.5, that's perfectly fine too. There, that's all the parts of the parabola.
Wait, so you take the absolute value of the,
Yeah, the absolute value of this number is the length of the lattice rectum.
The graph doesn't actually have to look like.
No, because it just says find the points, huh?
Oh, okay.
Okay, next. Now 67. What about when they give you the graph? Can you write the equation? No, that's too easy. Okay, which one? 55. Okay, what if they give you the graph? Well, of course, I'm going to give you this as well. So they give you a graph. Here, I'm not going to even put the xy axes on it. Okay, so here. The vertex is at 0, 1. And then they give you a point on it. Now, you have no idea what this point is, but that's okay, because that's actually easier. Okay, so here's the vertex. So this is a left-right parabola, so is the y squared or the x squared?
y.
The y is squared, so y minus 1 squared is equal to 4p times x minus 0, right? Now, how do I figure out what this p is? Well, there's two ways. Either they tell you what the focus of the directrix is, but they don't, or they give you a point. Well, if they give you a point that lies on the parabola, what do you think I'm going to do with that point? You just plug it in. So if I plug in 1 for x and 2 for y, what do you get? 1 squared is equal to 4p times 1.
1.
Right? So doesn't that mean 4p is 1? So doesn't that mean this number is 1? 4p is 1?
Oh, you don't have to divide by 4.
Yeah, you can, but then, okay, let's do it.
Because if you're trying to find
P is equal to 1/4 then.
yeah,
Plug it back in there. What is 4 times 1/4? 1.
no, that makes more sense.
But either way, it doesn't matter what. So what's the final answer? Y minus 1 squared is equal to 1 times x minus 0. There, that's the equation. Anyway, anytime they give you a graph with a point on it, you gotta plug it in, right? Now, do any of, see, like these, I don't think I would give any of these on a quiz. I would tell you what this is what I would do. Write the equation of this parabola. Give me some numbers.
2,
2 comma,
2,
no, something different. And then here's the focus. 2 comma negative, give me a number. 2, okay. Write the equation of this parabola. That's what I would give you. Well, here's the vertex, and since it's an up and down one, is the x squared or the y squared? Okay, so x minus 2 squared, right, is equal to 4p times y minus 3. Now, how do I figure out what p is? Well, p is the distance between the vertex and the focus. What is this distance?
1.
What? Who said 1?
It is 1.
If you have to go from -2 to 3,
Oh,
that's 5.
5.
So then, if p is, okay, let me just ask you, what's that number then?
1.
No, it's -20
Oh yeah, because it goes
because
down.
it's opening down. Can you guys do that? Yes, I think you can. Well, if I put it on the practice quiz, you should be able to. And then you guys said you had problems with 67. So let's look at 67. Well, I had all these words, that's why you guys got scared. Don't say that. So you have a suspension bridge like this in the shape of a parabola. The towers are supporting the cable are 600 feet apart, so this is 600 feet, and 80 feet high. So this is 80 feet high, like that. Or if the cables touch the road surface midway between the towers, so here's the roads. The road is like this. That's the road right there. What is the height of the cable from the road at a point 150 feet from the center of the bridge? Okay, so here's the center of the bridge. They're asking, if you go 150 feet this way, how high is the arch right there? So what we need to do is we need to write an equation of this parabola. That's what you need to do. So How do we do that? Well, you have to figure out where you want to put the origin. Shall we put the origin right there? That's probably the easiest thing to do. So here, this is the x and the y axis. So that means the vertex is at 0, 0. Okay, can we write the equation of this parabola? Well, we did it for all of these problems right here, right? So this is an up and down one, so that means the x is squared. So x minus 0 squared is equal to 4p times y minus 0, correct? I'm not going to write the minus 0. Now, either to figure out what this p is, either you got to know the focus, or they got to give you a point that's on the parabola. Do you know a point that lies on this parabola? Yeah, right here. What are the coordinates of this point?
380.
300, comma,
80.
does everybody see that? Because this whole thing is 600, right? So from here to here is 300, right? And then 80 feet up. So what do I do with that point? You plug it in. So if I plug in 300 for x and 80 for y, what do you got? What is 300 squared? 9 with 4 zeros, yeah? Equals 4p times 80. What I would do is I wouldn't even solve for p, I would solve for 4p. 4p is the number in the front that's wrong. 4p is equal to 90,000 divided by 80. Those cancel out. And does 8 go into 9,000?
No.
Yes, it does. It's 1,125. Yeah, it does. Okay, so that means that's what this number is. So that means the equation of the parabola is x squared equals 1125x. Except this is y, fool. Okay, that's the equation of this parabola. So now we can answer the question. If you go 150 to the right, how high up is the arch right there? In other words, on the parabola, if the x coordinate is 150, how do you figure out the y coordinate?
So you just plug 150
Yeah,
into x.
exactly. You just plug in 150 for x right there. So 150 squared is equal to 1125y. Can you figure out what y is? Do we need a calculator for that? No need! That's for weaklings!
Oh, square root.
What? We're talking about Willis. Okay, what is 150 squared? 70, well, what's 15 squared first of all? 225, and then with 2 zeros, right? Well, you don't need calculating for that. And so, to solve for y, you just go 22500 all over 1125. Look, no need calculator.
What was that?
Because, okay, just look at this. 1125 goes into 2250
Once. Twice, twice.
twice. So this goes into that 2 times, so the answer is 20 then.
What? No, it wasn't.
It was.
It's 20, the answer is 20. Yes, question?
You just make a proportion.
No. Because it's not proportional, that's why. It's a parabola. See, if it was a line, a straight line, then you could make a proportion. What, you got 20? Well, what did you, no, tell me what you did. It sounds interesting.
I did
600 over 80, 150 over y. And it came out to 20? Okay, well, you might have gotten the right answer. No. No. That's just lucky. Because then what if I give you a different number? What if I said, what if you go 200 to the right? Then would it work out? No, cannot. Is that what you guys do when you don't know how to do a problem? Just fiddle with the numbers until you get the answer in the back? All right, any other questions? Because today we have to move on to the ellipse.
What? We're spending 2 days on this.
Yeah, we did spend 2 days, except the first day, remember you guys didn't do anything?
Yeah, because you were sick. You didn't come to school.
So that doesn't mean it's a holiday for you guys. Okay, you know what? Just like yesterday, in just yesterday's lecture, I taught you everything about the parabola. today I'm just gonna teach you everything about the ellipse, but then you're gonna have 2 days to do the homework, right?
Oh.
11.3. So tonight, and then no class, and then Monday, no class, so. Come on, man. Mhm. Okay, the ellipse. Wait, let me get a cough drop before I start. Okay, did you guys read the book at all? That's a dumb question. Does any, oh gosh. You guys, you guys don't even bring your book to class. It's so sad. Okay, let me tell you the definition of an ellipse. The ellipse is a set of points in a plane such that the sum of its distances from two fixed points is constant. Okay, here are two fixed points. Okay, so if this is a point on the ellipse, then this distance and that plus that distance always has to be the same length no matter what. Okay, so if you want to draw an ellipse from this definition, you just get a piece of string. See, when you get older, let's say you do woodworking. Then let's say you want to make a perfect ellipse. This is how you do it. Okay, so you tie one end down here, right? It has to be two fixed points like that. And you tie another end down here. See, these points don't move. These are two fixed points. And if you pull the string taut, see, this is a point on the ellipse because this distance plus this distance is the length of the string. The length of the string doesn't change, right? Okay, here would be another point on the ellipse because this plus this is the length of the string. The length of the string doesn't change, it's constant. That one too. So if you take the set of all of these points, like this, see, you get an ellipse. You guys ever seen this before?
Circle.
No, it's an ellipse. You guys know the difference between an ellipse and a circle? A circle has a fixed radius. Like this. You guys ever saw, what's that movie I just saw? Taken 3.
Yeah.
Taken 2.
Oh yeah, when the girl had to draw the
She had to draw the map, right? So,
Find the dad.
so she got the shoelace. See, if you put these 2 points at the same place, like that, see, and then you get,
That's a circle.
yeah, you get a radius, right? Circle. That's ugly, yeah? Yeah, see, that's a circle. But then, if you have 2 fixed points, you get an ellipse. What would happen if these 2 points are farther out?
Wider.
Yeah, the ellipse gets wider. What if you bring the 2 points close together? Then it gets more circular, yeah? Until you get, when the 2 points are right on top of each other, then you get a perfect circle.
So the ellipse is not a circle.
No. No. Oh. A circle, again, has to have a radius. The radius, it stays the same throughout. It's not the same thing. Okay, anyway. So what you have to be able to do tonight is you gotta, and the next 2 nights, is you gotta find all the different parts of the ellipse, just like the parabola, you have to find all the different parts. Okay, but before we start, you see these 2 points? What do you think we call these 2 points? In a parabola, remember, what's the definition of the parabola? It's the set of points in a plane that are equidistant from a given point and a given line, right? You get the parabola like that. What did we call this fixed point right there? A focus. So a parabola has one focus, but an ellipse has 2 foci. Foci. So you have one focus here, and you have another focus there. Okay, halfway between the 2 foci, this is called the center of the ellipse right there. See now, if I draw a segment that goes like this, that's called the major axis. And if I draw a segment like this, that one is called the minor axis. See how the major axis is bigger than the minor axis? That's why they call it major and minor. Okay, so let me tell you about the equations. So these are the equations that you need to know. Okay? So if you have an ellipse where the major axis is left and right like this is what the standard equation looks like. the distance from the center to here, we're gonna call that A. Okay? And the distance from the center to the end of the minor axis, we're gonna call that B. A always has to be bigger than B, okay? Because the major axis is always bigger than the minor axis. So when the bigger number comes under the x's, then this means the ellipse is a left-right ellipse. The major axis goes left and right. However, if the bigger number comes under the y's, like this, A is always bigger than B now. Then the ellipse is this way. So the major axis goes up and down. Okay, so here, why don't I give you an example? We'll go through all the important parts of the ellipse. Now, this class compared to, in pre-calculus, we find all the parts, but in Algebra 2B, you don't have to find everything. You just gotta know certain ones. So let me give you something. X minus 3 squared over 25 plus y minus 2 squared over 9 is equal to 1. Graph this ellipse and label all the important parts. Okay, did you guys write this down right here? These are the equations you need to know, that's why. Okay, so this is how you do it. The bigger number is a squared, the smaller number is b squared. That's what you gotta know. Okay, which means what? What is a?
5.
What is b? Okay, that's all you have to know. Now to graph this ellipse, this is what you do. First you find the center. Just like circles. What's the center of this ellipse gonna be? Look, 3, 2. Here's the center of the ellipse, 3, 2. Doggone it. 3, 2. Now, all you have to do is figure out how much you go left and right, how much you go up and down, and you can sketch the ellipse. So, since this is a left-right ellipse, where the major axis is left and right, this number here is going to tell you how much to go left and right. So from the center, you just go 5 to the left, and 1, 2, 3, 4, 5, 5 to the right. This number here tells you how much to go up and down. So from the center, you go 3 down, and 3 up. And 2, there's your ellipse. It's really easy to graph an ellipse. You plot the center, then you take the square root of that number, that tells you how much to go left and right. You take the square root of that number, that tells you how much to go up and down, and you just go right. So this is the major axis, this is the minor axis. Now, in this class, like I said, you don't have to find all the parts, we're just going to find the more important ones. These 2 points, what do we call these 2 points? These are the endpoints of the major axis. We call these vertices. Like a parabola has 1 vertex, right? But an ellipse has 2 vertices, so we call it like V1 and V2. So how do I compute these points? I just showed you how to do it. How much did I go to the left and the right? 5. So you just go 5 to the left. So if you're at 3, 2 and you go 5 to the left, where are you going to be? -2, 2. And then if I go 5 to the right, where are you going to be? 8, 2. Now if you have to count just by ones, then do it. Okay, these 2 points are called the endpoints of the minor axis. There's really no name for it. We just call it the endpoints of the minor axis. So how did I get to these 2 points? Didn't I have to go 3 up and 3 down? Okay, so if I'm at the point 3, 2, and I go 3 down, where am I going to be? 3, -1. And then if I go 3 up, you're going to be at 3, 5. Those are the endpoints of the minor axis. Now, in Algebra 2, besides these 4 points here, all you gotta know is where are the foci? Now remember, on an ellipse, the foci always lie on the major axis, okay? Darn it, I shouldn't erase that picture, but I did, okay? Anyway, you have an ellipse like this, major axis, minor axis, here's the center. The 2 foci always lie on the major axis. the distance from the center to the focus, and it doesn't matter which one, is going to be c. Now you might be saying, yeah, but Mr. Park, I got A and B. How do I? There's no c here, and that's right. When you have an ellipse, this is how you figure out what c is. C squared equals a squared minus b squared. So I'll box that and attach it to this box here. Okay, so if I want to figure out what c is, you have to use that equation. C squared is equal to a squared minus b squared. So in this problem, what is a squared? 25. What is b squared? Look right here. 9. Subtract them and you get 16. So if c squared is 16, what is c? 4. That tells you the distance from the center to each focus. So here's the center. C is 4. To get to the first focus, you have to go 4 to the left. So if I'm at the point 3, 2, and I go 4 to the left, where are you going to be? We'll call this F1 for first focus. Go 4 to the left. Negative 1, 2. And then to get to the other focus, you go 4 to the right. 1, 2, 3, 4. Right there. What's the coordinates of that focus? 7, 2. See how I make mine always come out to nice whole numbers? Like the book, sometimes they don't even think about what numbers they're using, so you might have like a radical 7 there. So that means you gotta know radical 7 is like 2 point something. So isn't that pretty easy? For the ellipse, all you gotta know is figure out where the center is, but then you just look at these two right there. Then A tells you how much to go left and right, well, if A is under the axis, right? And then this number here, the square root of this number tells you how much to go up and down. Then you figure out what C is, and then you just go that much left, that much right. It's pretty easy. Okay, but the problem is, they're not gonna always give you the equation in this form. So sometimes you're gonna have to complete the square, just like you did on the problem. So let's do a problem where you gotta complete the square. In fact, I'll take one right out of the bowl. Oh, this is okay. All right. Okay, in the book, let me do an even problem. Shall we try 52? See now, this is called general form, where you have one side 0 and everything else on this side. So in order to put it into standard form, the useful form, you have to complete the square. So it's easy, it's not hard, okay? So you look at the two x terms like that, put them together. See, the coefficient was 1 here, so that makes it easier. Okay, now look at the two y terms. Can I factor out anything from these two?
9.
A 9. So you factor out a 9, what's left? From the two y terms here. Y squared minus 2y, leave a space, and then this number, throw it on this side. Okay, now you guys remember how to complete the square, right? What number do I have to add there to make a perfect square? You take half of that number and you square it, which is 9. If you add 9 on the left, you have to add 9 on the right. Okay, what about here? What do I add right there to make a perfect square? You take half of that number and square it. 1. But what did you actually add? You didn't just add 1, you added 9 times 1.
So 9.
So if you add 9 on the left, you have to add 9 on the right. Okay, so what do you have so far? You have x plus 3 quantity squared plus 9 times y minus 1 quantity squared equals 9. Now, in order to make standard form, you need this side of the equation to be 1, right? So how do I make this side 1? Divide both sides by 9. So if I divide both sides by 9, you're going to get x plus 3 squared over 9 plus, what happens when you divide this one by 9? y minus 1 squared over 1. So is this a left-right ellipse or an up and down ellipse?
down.
Look, the bigger number's under the x's. Look, the bigger number is a squared. The smaller number is b squared. If the bigger number is under the x's, then the ellipse is left and right. If the bigger number is under the y's, then it's up and down. But this one is under the x. So let's just do this quickly. Where's the center of this ellipse?
-3.
Negative 3, 1. Okay, here. So negative 3, 1. That's the center. Okay? Now, how much do I go left and right? Well, if a squared is 9, what is a? 3. In fact, why don't we just figure out everything right now? If b squared is 1, what is b? 1. And then how do I figure out c? C squared is equal to a squared minus b squared. So that would be 9 minus 1, which is 8. So if c squared is 8, what is c? Square root of 8. Or if you want to simplify it to 2 root 2. But I think square root of 8 is more useful because that's 2 point something, right? Okay, so to graph this ellipse, this number tells you how much to go left and right. So you go 3 to the left, whoo, 3 to the right, whoo. And then this number tells you how much to go up and down. You go 1 up, 1 down, and there's your ellipse. That's how you graph it. And then do I need to go through how to find all the different points? You guys can do that, right? Anyway, to get to the foci, from the center, you would have to go square root of 8 to the left and square root of 8 to the right. See, that's why they come up with ugly numbers like this. Like when I'm going to give you a problem, I'll make it come out so it comes out nice. So the last question I have for you today is, why do we study ellipses just so teachers have jobs? No, because there's real life applications of this. No way. I'm going to tell you what it is, okay? If you have an ellipse, these are the two foci. Let's say you have sound waves, or it doesn't matter, radio waves or light waves, it doesn't matter. If they emit from one focus like this, it's going to hit the ellipse. Where do you think it's going to bounce to? The other focus, like that. So it goes like this. Now, can you think of where this has a real life application?
Art.
Art. Oh, maybe art. I don't know.
It looks like art.
Yeah, but I'm talking about. Okay, have you ever been to a museum that has like a whispering chamber?
Like bats, yeah? Like how bats communicate.
Okay, I went to this museum, I forget, I think it was Boston, I'm sure they have it all over the United States. I'm not sure if they have one in Hawaii, but you climb the stairs, and then you're up at a podium, and then this is like way across the building, this is like 50 yards away. And another person, they climb upstairs, they're over there, and you can be whispering like this, and you can hear each other perfectly, even though you're 50 yards away. You know why? Because of the ellipse. So what they build, the whispering chamber, so they build like, they figure out these are the two foci of the ellipse. So they build as much of the ellipse as they can right there. And over there too. So all the sound that goes over here, what do you think happens? It bounces off and goes to the other focus, like that. Now you guys are taking history. What president are you guys on now?
Jackson.
Okay, so you guys passed John Quincy Adams, right? Didn't your teacher tell you the story about him? I saw the picture in your history book. John Quincy Adams was sitting on a bench over here, and then he was pretending to be asleep like this. That's a famous picture. And you ever take the tour of the building, the Capitol building? You guys never went to Washington, D.C.? Oh my God. Okay, anyway, he's sitting on a bench here, and he's pretending to be asleep. And then the other party is at this other focus over here, and they're all standing, and they're talking like that. But he can hear everything they're saying. You know why? Ellipse. And then, just 2 years ago, I found out another application of the ellipse because I had to have a... You guys ever had kidney stones? Believe me, you don't want to have a kidney stone because that's like super painful. The only thing they said you can relate it to is like having a child. No, for real, the pain is intense. Because as the stone travels through your kidney, it's so painful.
Have you had one?
Yeah, I had many. No, so no, you believe me, you don't want to have a kidney
So
stone.
basically, you experience birth.
That's why men do not experience giving birth to a child. So that's why women, they do, right? So they said the only thing you can compare giving birth to a child is having a kidney stone.
Oh.
So anyway, as a kidney stone travels through your kidney, it's like a really jagged rock, that's what it is, yeah? It's super painful, so sometimes you gotta go to the I had to go to emergency. I tried to finish class one day, I had a kidney stone, I was going, oh, my back is sore. Oh, I can't do anything. And you get all pale and your temperature drops and everything. You have to go to emergency because it's so painful.
It's hard to get out.
Well, some people just are more prone to get kidney stones than others. But it's like if you don't drink enough water, basically.
Oh.
Yeah.
Oh no. How'd you get out of it?
Huh?
Yeah, go use the restroom.
Yeah. But then you should hear, if you went to the restroom, you should hear the kidney stone story. Okay, never mind. Anyway, so the only way is it passes through your kidney and then it drops into your bladder and you pee it out. That's what might happen right here. But what happens if the stone is so big you can't pass it? You know what I mean?
Surgery.
It's too big to pass through your system. They have to blast it with sound waves. No, because if the stone is too big, how you pee it out? What if it doesn't drop into your bladder?
No, just poop it.
Bladder, not
You don't
larger
poop
than-
it out from your bladder.
I know, but instead of peeing.
You don't get to
Oh my God,
choose.
are you kidding me?
Just take like glass. What is that thing called?
No, it doesn't work like that. So this is what the doctor told me, and then when he started telling me, I said, hey, that's an ellipse. And he said, you're right. So if the stone is too big to drop into the bladder, you have to get this thing called either surgery, they can do surgery, but they don't recommend it, or you can get this thing called a lithotripsy. So what you're doing is you're lying in a water thing, you're lying in water, and here are the two foci of the ellipse, and one, this is where they place your kidney, where they think your kidney stone is, so they line you up perfectly, and then over here they have sonic waves, like that. Well, no, they put you to sleep though, so all the sound that comes out goes to the other focus, and it just blasts the kidney stone into pieces, and then you can pee it out.
Ah, is it so wait? You did do that.
Yeah, I did that.
So it's sore when you woke up.
A little bit. But then it's more sore when you pee it out.
Ah.
That's why you don't want to have kidney stones. Drink a lot of water. Don't
Kidney stone.
lithotripsy. Anyway, yes, there's many applications of conic sections. That's why we're learning things.
It's not all that. Specific.
Wait, no, I gotta tell you one more story.
Okay.
When I took engineering classes in college, there was a contest for the engineering class. So they said they're gonna put water in a rod like this, and then they're gonna insert a thermometer, and then you have to build a device, and you're gonna leave it in the sun for an hour. Whoever can raise the temperature the highest is gonna win. So you know what I thought? I thought, I'm gonna build a parabola. No, I thought this is a guaranteed winner. So you make a paraboloid, and then right where the the thermometer thing's gonna be, that's where you put the focus. Yeah. Now, first of all, it's very difficult to build a perfectly shaped parabola, but I tried my best. And then I don't know how I made it. Some kind of what's the shiny material? It's mylar or something? No, not metal. Anyway, so the thing, I was second place, but you know who won? You know what won first place? I couldn't believe this. They just did brute force. They had no, there was no like mathematics behind their thing. All they did is they got a gigantic box, I think a refrigerator box, and they lined it with aluminum foil. and they just aimed it at the sun, and that thing won. But I guess it was so hot in there, it didn't really matter if you're focusing the heat or not.
Why don't you just like,
So no, I guess the lesson is, sometimes brute force is gonna win out, yeah?
why don't you
It's
just
like
get,
sumo wrestling, right?
why don't you just get like a little like tin can, put the thermometer in there.
No,
And then put it-
they have it set already into the thing, you have to build the device.
Yeah, so get like a box around it, and then make a fire underneath it, so the box just heats up, like a stove or an oven.
Oh, I never thought of that.
I could have wanted this.
No, that,
Like roasting a pig, like how it just.
Oh,
sits
no,
up-
yeah. Why didn't I think of that? No, for real, that's genius. You put a box and you fill it with flammable material,
Just put fire.
and then you have like a, what do you have, the magnifying glass?
Okay, they could do that.
And then you focus the sun on it, and the thing
That's
will start heating up, right? Or what then just take a match and throw it in there, right? Yeah, that's genius. No, but you're supposed to just leave it there. You're not supposed to do anything. You're supposed to just leave it.
No, just set the fire underneath. Just
So I
walk
think
away.
you need the magnifying glass to focus the light and start the fire, though, yeah.
No, but I mean, it's like if you set a fire underneath it.
No, but you can't though. You just have to put the box there. So you have to have somehow something to ignite the fire.
And just like tape a magnifying glass.
That's what I'm saying.
Oh. Or tape it so that it lines right by the wood.
Or just tape it so like this, like the match, it's gonna, you drop it and
Yeah.
it'll light the match.
Like Toy Story.
No, that's clever, but yeah. Wow. Why didn't I think of something like that? No, no, why did I think of that? No, because when the professor was telling us about this game, I thought, oh, I'm going to do this already. I'm going to win. Nobody else knows about the parabola except me. And nobody did, except I came in second because the other one. But then if I thought of his idea, I would have come in first. Just set the whole thing on fire. Okay, I taught you everything about the ellipse right there.
Sorry, can you use the bathroom?
Yep. So you can do both homeworks with everything I taught you right there. Yep.
Magic one.
Yep.